All right, today we talked about the multivariable equations, and then we called them literal equations, where we said they're pretty much just formulas, and what we were doing was we were rearranging for the specified variable of the formula. This is exactly what we do when we solve equations. They're treated the same way. We have example 1. Example 1 is a nice two-step equation. We want to isolate x. It says solve for x. So in order to get x alone, x is part of this binomial. We need to get the 5 away from the x to start isolating. So we're going to add 5 to move it to the other side of the equal. And that's going to give us 2x equals 18. 2 times x. So to undo the multiplication, we're going to divide both sides by 2. And it's going to tell us that our x is going to equal 9. Now we could check this by plugging 9 back in, just to verify and evaluate it. I'll get 18 minus 5, which is 13. So it checks and works. This is our literal equation, and if you notice, you'll see that it's set up very similar to our example number 1. The difference being these are all letters as opposed to numbers, but our process will be exactly the same. We're trying to get x alone. So we want to start by adding or subtracting anything on the same side as x. So we have a minus b, so to move it to the other side, I'm going to say plus b. It cancels out on the left, leaving just the ax. However, c plus b, these are not like terms. They do not combine, so we're just going to write c plus b. Now, we're still trying to get x alone. This is a times x, and undo the multiplication. We're going to divide both sides by a. The a cancels on the left, leaving just the x. And on the right, these are all unlike terms, so we are just going to leave them. C plus b divided by a is our answer. That's as simple as that's going to go. So we were going to use the same operations just as we've always been doing. So similarities. Is that we're still going to use opposite operations to isolate the variable. So opposite operations to isolate the variable. And we have differences too. Differences. The difference is, in example 1, we're able to come down to this nice, pretty answer of 9 because we were able to combine like terms. Example 2 did not give us that opportunity because there were no like terms, so we're unable to combine like terms. So really, all we're doing is changing around the order. You're not really able to get rid of anything along the way for the most part when we do these problems. All right, we started with some of these one-step equations where you only had to do one thing to get the variable by itself. So we just have to look and see what's going on. We want to solve for w in number 1. So here's w. L is multiplying to w, so to get the w by itself, we want to undo the multiplication using division. It's going to cancel it on the right, so it says it's just going to equal w. And on the left, what we're left with is these unlike terms that won't simplify, so we're just going to say a divided by L. Okay, 2 and 3 are pretty much the same, so we're going to try number 4 here to look at it a little bit differently. We're trying to get t alone. So t is part of this monomial. There's no addition or subtraction to get rid of. But I see that p and r are both multiplying to t. To undo multiplication, you've got to do division. I'm going to recommend we do it all at the same time. We want both p and r to be divided away. So we're going to divide both sides by pr. On the right, they're canceling out, which leaves the t by itself. On the left, I divided by PR does not simplify because those are not like terms. So there's your answer, I divided by PR. Okay, 5 is almost the exact same kind of problem. So you would use the same process. Number 6, it's the same kind of problem, but it looks a little different because we have this symbol for pi in there. However, we're still just going to treat it the same way. We're trying to get r by itself. So here's our r. R is in this monomial. There's no addition or subtraction. There's only multiplication going on. So to undo multiplication, we're going to divide away the things we don't want on that side, which is 2 and pi. We're going to do the same thing on the other side of the equal. They cancel on the right, leaving r by itself, and we're left with c over 2 pi for number 6. Right. Number 9 looks a little bit different, but our process is going to be the same. We've got to think about where is our variable that we're interested in. We're interested in m. M is part of this monomial fraction right here. So the only thing that has to move to get m alone is this v on the bottom in our denominator. So if we multiply this side by v, that's going to cancel out, leaving m alone. We've got to make sure we multiply by v on this other side. And we get d times v is going to equal m. Okay. All right, let's do a couple of these longer problems on the back of our note page here. I gave you some helpful hints to help you remember. When we're simplifying expressions, we used PEMDAS, parentheses, exponents, multiplication and division, or addition and subtraction. But when you solve, you're going to do PEMDAS backwards. We want to look for any addition or subtraction first, then multiplication and division, then we can get into our parentheses. When we have fractions that we're trying to get rid of, we want to multiply by their reciprocal. The last step is usually to divide by whatever's in front of your variable. We're going to divide that off. So let's take a look at a couple of these. So number 10, that's our area for a triangle. All right, so let's look. This is a monomial. It's one single term. There's no addition or subtraction going on. So we got to look at the multiplication and division is a thought, and it also, we do have a fraction, so we're going to need to multiply by a reciprocal here. So let's go ahead and get rid of the fraction to make it a little bit easier to look at. The reciprocal of 1 over 2 is 2 over 1. And we'll multiply both sides by 2 over 1. The 2's cancel, the 1's cancel, and I'm just left with BH on the right. On the left, I have 2 times a over 1, which will just leave me with 2a. We're still trying to get h alone, so here's my h. It's being multiplied by the b, so to undo the multiplication, divide. And I'll have 2a over b equals h. So these next couple work kind of the same way. So I want to look at 13, because 13 shows us something a little bit different that might be a little confusing. So we're trying to get b. Here's b right there. I keep asking, is b part of a monomial or a binomial? B, this is one single term that it's in. This fraction is one term. That's a monomial. So there's nothing being added or subtracted to this fraction, so we're going to jump straight to getting rid of the denominator. The denominator is d, so we want to multiply this side by d, and along with the left. So we'll have a times d equals, those guys cancel, b plus c. Now we have a binomial. Here's your b that's part of a binomial. Now you have to add or subtract first, which is going to subtract the c off. And we have a d minus c equals b. All right. Try to hit some of the different kinds here so we can see. Let's look at 18. We want a. A is inside that parenthesis. Parentheses are the last thing we deal with. We need to get rid of everything on the outside of the parenthesis first. So when I look on the outside, I see there's an n multiplying to the parenthesis. So let's go ahead and undo that multiplication here and divide. And I end up with s divided by n equals, now when I do that, there's nothing left, so the parentheses can drop. A plus 1. I'm still trying to get a alone, minus 1. This whole fraction will have minus 1 after it. So I'm going to get s divided by n minus 1 equals a. Alright, here's our last two that I want to show us. These are the ones I told you to star because I see these show up on tests all the time. They're very important ones to remember. It's our formula for Celsius and the area of a trapezoid. So for number 19, we want to get f alone. Here is f. F is inside the parentheses. That means we do that part last. We want to get rid of what's on the outside first. The outside of the parenthesis is 5 over 9. So I'm going to multiply by 9 over 5 on both sides. 9 over 5. Okay? The 9 cancels with this 9. 5 with 5. That gets rid of everything on the outside of the parentheses, so we're just left with f minus 32. And then on the left-hand side, I have 9 times c over 5, or I could say 9 over 5c. To continue isolating f, this is f minus 32, so we're going to add 32 to get f alone. The whole monomial here will say plus 32 when I rewrite this. So we have 9 over 5c plus 32 is going to equal f. All right. One last one. Let's do our trapezoid one. We want to get b1, which is here inside our parenthesis. We want to get rid of everything on the outside of the parentheses so we can work into our parenthesis. Let's go ahead and get rid of the fraction first, just so it's out of our way. The reciprocal is 2 over 1. Okay. That makes your 1/2 cancel to a 1. It's just gone now. And I have 2 times a over 1, which will just leave me 2a equals, I still have that h there. I haven't done anything with them yet. Okay. Now I'm trying to get to b1. He's still inside the parenthesis because there's still something on the outside. H is multiplying to the parenthesis, so we're going to divide by h to unmultiply. So we have 2a divided by h equals b1 plus b2. Trying to get b1 by itself, this is now a binomial. We're going to subtract off b2, this whole fraction minus b2. So we have 2a over h minus b2 equals b1. Alright, so hopefully this will help. You guys can pause this when you need to, restart, listen to it, and hopefully that will help with any questions you may have. Have a good weekend.